Welcome to part 2 of Module 4. In this part, we are talking about how you could use multiple representations within intensive intervention. So I hope that you will learn in this part what we mean by concrete, representational, and abstract. Now, where are we? Oh, there's our blue arrows and there's our DVI diagram. So the part of this module that we're really focusing on are the orange parts, the part here and the part here. And we've been talking about those as our instructional platform. And I've really got our DBI framework right there, but we could also think about using this within the instructional adaptations, which we'll talk about in a later module. Now remember our instructional platform. We've talked about this quite a bit, but this is where we're going to figure out the student's strengths and weaknesses. We're going to develop a scope and sequence for intensive intervention, and then we're going to identify the instructional platform, either starting with an evidence-based intervention, or if that's not available, using an evidence-based strategy or strategies. And that will help us do DBI. So where we start with our instructional platform right up here, and then we're going to progress monitor that to see if it's working all right. And then if students are responsive, we'll continue using that same instructional platform. But when students are non-responsive, we'll do a diagnostic and then we'll make an intervention adaptation. Now, the things that we're going to talk about today in terms of multiple representations, you'll probably be using them here within the instructional platform, or you might be intensifying or adapting the intervention using different types of multiple representations right here. And then as always, we're going to continue to progress monitor to make sure that those adaptations are working okay. Now, one of the things that we want to rely on in the instructional platform are evidence-based practices, either an evidence-based intervention or an evidence-based strategy. And you've seen this slide before, but when I think about the evidence in terms of intensive intervention for students with mathematics learning difficulties, I like to rely on this list. This comes from the Institute of Education Sciences, and I've kind of put together my own list. And I know you've seen this before, but I'm going to show it to you again. So when I think about intensive intervention, I know that it needs to use explicit instruction. That is an evidence-based strategy. Intensive intervention should also use multiple representations. That's what we're going to talk about today. I also want intensive intervention to have concise language. And then when we're thinking about the strategies that we employ within intensive intervention, we should use fluency building, effective problem solving, and also a motivational component. And right now, we're going to focus on that multiple representations component. So in this part, we're talking all about multiple representations. And when I think about multiple representations, and when I want you to think about multiple representations, I want you to think about the concrete, representational, abstract. Sometimes people call this the concrete, semi-concrete, abstract. Whatever you name it, the idea here is that we are using multiple representations to help students understand the concepts and procedures of math. Now you'll notice that my concrete representational abstract is kind of messy right here. And that's because I want you to think about these things as overlapping. Sometimes you might see the concrete representational abstract as a sequence where this comes first and then this and then this. I don't want you to think about it that way. Instead, I want you to think that we are always trying to help students understand the abstract of mathematics. And sometimes you might pull in the concrete to help students understand the abstract. Sometimes you might pull in the representational to help students understand the abstract. So it's not a sequence. Instead, it's a framework of representations that we can pull in to help students better understand mathematics. So let's go ahead and talk about the concrete of mathematics. And I'm going to move over here to my document cam. Now, when we're talking about the concrete of mathematics, we're thinking about three-dimensional objects that we can use to explain different math concepts and procedures. So, for example, I might use Cuisenaire rods to show that 3 plus 2 equals 5. These are also really, really awesome for fractions. Maybe I'll look at my base 10 blocks here and I'll see that I'm representing 54. These are also really, really nice for decimals. Perhaps I would look at my fraction tiles to show the fraction 3/10. And this is a three-dimensional object because I can touch and move it around. Maybe I have my frogs to help demonstrate subtraction. If I want to show 5 minus 3, I start with 5, and there I take away 3. 5 minus 3 is 2. And I also could use a concrete manipulative such as a geoboard. Here on this geoboard, I'm showing the fraction 3/4. But all of these are concrete objects because they're three-dimensional. You can see I can touch and move them around just like this. And all of these can be used to demonstrate different types of math concepts. Now, there are hundreds of math manipulatives available. This is an example of just a few. But in the rest of this part of this module and throughout some of the videos that we're going to watch, you're going to see many more manipulatives used. And I also hope that you'll add to this list and share some of your favorite manipulatives with your colleagues. Now that we've talked about concrete objects, let's watch Lou use concrete objects in this lesson about regrouping. So I'm going to go ahead and step off to the side so you can watch the entire thing.
So let's do it differently. We can use another way to do it. So I have some materials for you to use. So these are called base 10 blocks. And I'm going to introduce you how to use base 10 blocks to solve subtraction problems. So these are called flats, and these are rods. Yes. And we also have cubes.
So flats, rods, and cubes.
Good job. So let me introduce you these.
All right, one thing before we continue watching this video with Lou and Nellie. Lou, when she introduced the manipulatives, she talked about the hundreds as flats. She talked about the tens as rods, and she talked about the ones as cubes. Now that's a fine way to describe those as cubes, but technically if you looked in the base 10 material, often those are called units. So instead of calling them flats, rods, and cubes, they are flats, rods, and units. And I think it's totally fine here. The word cube is relegated for thousands. It's a big thousands cube. But since Lou is not using that in this lesson, it's totally fine that she's using cubes, and it seems like the student understands. So let's go ahead and see how Lou uses these base 10 blocks in a concrete way to help this student understand what's going on in addition.
Cubes. We're also going to use a place value mat. These are hundreds, tens, and ones. So now we have these cubes, and we call them, or we represent ones. Wow. So 1 cube is 1. So we have, let's count it like this. So 1, 2, 3, 4. So we count these ones like this. So cubes represent ones. And now we have rods. Rods represent tens. Why do you think rods represent tens?
I don't know exactly.
Yeah. So you see here, it seems like this one rod is made of cubes, right? Mm-hmm. Let's count how many cubes he has.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Good job. So we use 10 cubes to represent one rod. 1 10. Okay, now we also have these flats. One flat represents 100. Why do you think it represents 100?
Well, it looks a lot like a 10.
Yes, it's made of these tens. Let's see how many tens it has.
10, 20, 30, 40, 50, 60, 70, 80, 90, 100.
Good job. So one flat represents 100, and 100 has 10 tens, right?
All right, so that was a really nice example of how you could use concrete manipulatives to do a lesson on regrouping. And we didn't even see the regrouping, but we did see how Lou was really talking with Nellie about how 10 ones represent 110, and she was able to touch and show that, and then how 10 tens represented 100, and Nellie was actually able to count that to get that concept. So the nice thing about concrete materials is that if you look at the paper on the desk, we're just solving addition problems. And for some students, they can solve those. But for this problem, this is not an addition problem, this is a subtraction problem, I'm sorry. But 204 minus 167, that would be a hard problem for many students to solve. And so later Lou uses these manipulatives to help understand, well, do you have 6 tens to take away? If you don't, you need to regroup, and to be able to visually show students that that example. So now you're going to think about concrete materials. So if you look in your workbook, activity number 5, I want you to list 10 concrete materials that you might want to use within intensive intervention. The idea here is that if you've thought about different concrete materials to use, you're more likely to use them. Now that we've thought about the concrete, which was right here, I want to talk a little bit about the representational. Now, the representational in mathematics are 2-dimensional images. So I've got some here on my slide, and I can use these to show different mathematics concepts. So for example, I've got these bears here. So how many bears do I have in this set? I have 2. And to that, I'm adding how many bears? 1, 2, 3. I'm adding 3 bears. So the idea here is that I can touch the 2 bears, 1, 2, and that represents the abstract form of this number, and I can touch the 3 bears. So they're just 2-dimensional images. I could do this in the concrete, but I can also do this in the representational. Here with this set of base 10 blocks here, I can count these, so I could touch and count them, 10, 20, 30, 31, 32, 33, 34. That would represent the number. I'll write it over here if I find some blue space. 34. I can use this clock. So this is something I can touch it, but I'm also have a visual here, and this tells me that it is 10. What about 10 time is it? 10, 10 there. And then I can also use this representation here if I was trying to figure out, either could think about like the volume of different types of cones. But the idea with the representational is that they are linked to the concrete. So I might have a clock that I can actually touch and move the hands on, and then I have a representation of that clock to practice telling different time. As we already saw, we could use those base 10 blocks. So I can touch the base 10 blocks, but then I have visuals of base 10 blocks, so I can touch those to figure out how many 10s and 1s I have. And the same thing, I could do this with the frogs or counters or the Cuisenaire rods. If I was thinking about adding 2 plus 3, I could do that in the concrete, but I can also do that in the representational to figure out what the answer is, or sum is, to 2 plus 3. Now we're going to watch a tutor named Dariella, and she is going to work with Sadie, and they are going to solve a problem in the representational. Now we're going to start with them about halfway through the lesson. So they've already worked on solving the word problem, and now Sadie's going to do some drawing, so a representation of the word problem. Let's go ahead and check out their work.
Okay, so now let's draw it. So we're going to solve the problem differently, okay? So here's your marker. You can draw it here. Okay, so let's see this group. Here are 3 Pokemon balls. So let's draw 3 Pokemon balls on this side. On this side. Good job. You can just draw circles for the balls. 1, 2, 3. Great job. Now we're going to add the 5 Pokemon balls in here, okay? Let's draw 5 Pokemon balls. 1, 2, 3. Good job. 4, 5. Great drawing. Okay, let's count how many Pokemon balls we have.
1, 2, 3, 4, 5, 6, 7, 8.
We have 8 Pokemon balls. Great job. So now let's draw 8 Pokemon balls on this side, so that way we have the same amount. 2, 3, 4, 5, 6, 7, 8. Are both sides the same?
Yeah.
Yes, great job. So we have how many Pokemon balls here?
8.
And how many Pokemon balls over here?
8.
8. Great job. So that means that 3 plus 5 is the same as 8 Pokemon balls. That's great.
All right, so that was a nice example of using the representational. So before I showed you prepared representations, but many times the representational can be drawn by you, the teacher, or by the students. Now there's another thing about the representational is that it doesn't have to be a nice picture on a page. It can be a two-dimensional image provided virtually. And so there are so many virtual manipulatives that are available these days. But they're representational because they're not three-dimensional, they're two-dimensional. Most tablets have different apps that have free or really inexpensive virtual manipulatives. And another nice resource is the National Library for Virtual Manipulatives. So just as you made a list of 10 concrete materials that you might want to consider using within intensive intervention, I want you to spend a little bit of time exploring virtual manipulatives. You might have some virtual manipulatives to use through your mathematics curriculum, but go online, go on your tablet, go on your phone. There are apps that you can actually use. There's a Geoboard app that I have on my phone. You can download it for free and then show students different geometric concepts and different fraction concepts. So I want you to identify 10 virtual representations that you could use within your intensive intervention. Now finally we get to the abstract. That's where we're showing we're showing math with numerals and symbols. So for example, I did that problem already. I might show math with 2 plus 3 equals 5. So here I have both numbers and symbols. When we talked about the number 34, I could show 34 with numbers and symbols. If I wanted to get a little bit larger, I could show this number 1,690 with numbers and symbols. But I also might think in an algebraic way. Maybe I'm solving y equals mx plus b. Probably a lot of you middle school teachers have to work on that. That is solving problems with numbers and symbols. And I would even argue if I was talking about geometric shapes, and I might say, oh, this shape has 8 edges. I would say that not only are the numbers an abstract form of mathematics, but also the words are an abstract form of mathematics, and students need to know all of those. Now I'm going to go ahead and erase my abstract forms. I'm sure you're pretty familiar with the abstract in mathematics because most often that's how students have to solve mathematics. And in fact, that's why we need the concrete and the representational. I'll talk about those, probably emphasize those a little bit more. I know that your students are seeing and solving math in the abstract, but we need the concrete, let me move my fingers there, the concrete and the representational to help them really understand what's going on in mathematics. So our final video that we're going to look at here, we're going to go back and see Dariella. They're going to finish this lesson about solving this problem of, I think it's 3 plus 5. Let's go ahead and see how they practice it in the abstract.
Let's move on to writing out our problem and working on mathematical symbols. So let's write our 5 Pokemon balls first here because we can start with the greater number. Yes. But do we always need to start with our greater number in addition?
No.
No, we don't. Great. So we can start with number 3 or number 5 because in addition, it doesn't matter the order of our numbers. Okay? Let's start with number 5. Let's draw the 5 right there. Great. Number 5. Great job. So now we have 3. So let's put our number 3 right there. That's great. Okay.
you'll just like kind of just help her rewrite the number 3.
Okay. Great job writing the number 3, but I think you have it backwards. Do you want to try it this way, like this one?
Yeah.
Okay, start. You can, if you want, you can cross it out and write it under here. Do you want to try? You want to copy this one? So we're gonna go. There we go. Great job. Awesome. Okay, so 5 plus 3. What does the plus sign look like?
Like a X almost, but it's like a T, lowercase t.
Great job. Can you draw it for me? Excellent. Okay, so 5 plus 3 equals, do you know what the equal sign?
Yeah.
Okay, let's draw it. Equals, what number?
8.
8. Great job. Wow, grade 8. So let's repeat the equation. 5 plus 3 equals
8.
8. Great job. You want to try that again?
Yeah.
5 plus 3 equals 8. Great job. So we know that 5 plus 3 is the same as 8. Great job. High five. Let's work on.
All right, they did a nice job there working in the abstract. And I just want to make a few comments on the teaching that Dariella is doing. When the student made a mistake, so she ended up writing, and it's right there, she wrote her 3 backwards, which is a pretty common occurrence for students her age. And after I think that the teacher said, like, oh, should I correct this? She did a really nice job of the correction. So she didn't just like rewrite it for the student, but she gave her an example. So she pointed to the number 3, which is someplace in this problem. The student could see it. It's pretty hard for us to do that. But she's like, oh, you need to write your 3 like this one. And so then the student was able to model her 3 on that. Another few things about the teaching. So this is a part where the student, she's kind of engaging in a hybrid of guided practice and independent practice. So the teacher is still really helping the student work through the lesson, but like the student is doing most of the work on her own. But there's 2 mathematical things that the teacher's doing here that I think are really great. First is she talks about the commutative property of addition. Now, while she doesn't introduce that vocabulary to the student, they talk about that the order of the numbers doesn't matter. But she does a really nice job here is that she always says that the order of the numbers in addition doesn't matter, so that the student may not then think that that also applies to subtraction, which it does not. The other thing is that she's got a nice attention to her math language. So she's using formal names for the signs, so the plus sign and the equal sign. She also describes the equal sign as meaning the same as, so the student can understand the equal sign as balance. So she's taking a lot of things that we're going to talk about throughout these modules. So here we're focusing on the representational, but you can see she's using explicit instruction, which we talked about previously in this module. And she's also attending to math language, which is what we're going to talk about next in this math module. So there's a lot of things going on there. And I think it's also a nice thing to see that explicit instruction never stands alone. You're always using explicit instruction with representations, with a focus on language. You have a motivational component. Look how she gave the student a high five. And here they're focusing on fluency, which we'll talk about in later modules. So all of these things combine to be a part of the student's instructional platform. So in this part, we've been talking about these multiple representations. And it's really important because, as I said before, so many students always see mathematics in the abstract. And in the young grades, in kindergarten, 1st and 2nd grade, we do see a lot of use of concrete materials and a focus on the representational. But around 3rd grade, there's usually a pretty steep drop-off in terms of the use of concrete materials and an emphasis in the representational. And that's when math is getting more complicated. So if you're teaching more complicated math, if you're teaching the difference between total surface area and lateral surface area, it's good to use representations, but it's even better to use concrete objects that students can touch and understand. Oh, I don't include the base in this calculation, but I do include it in this other calculation. If you're teaching anything about fractions, the concrete will really help students understand fraction concepts or demonstrate different types of fraction computation or decimal computation in the same way that the representational can help out. So the idea here is that when we are teaching math and teaching students to solve abstract problems, we use the concrete and the representational, or the concrete or the representational, don't always have to use all three of them, to really help bolster the deeper conceptual understanding of these mathematics problems. Now I want us to look at our next activity. You're going to watch a student named Asher. He's going to solve a problem 6 plus 8. And I'll go ahead and spoil it. He's not going to solve this problem correct. And so I want you to now think of like 2 concrete activities that you could use to help Asher solve this problem correctly. So what might be some of those manipulatives that you listed that you could use to help him solve 6 plus 8? Then I want you to describe 2 representational activities. And I'd actually like you to draw these out. How could you help this student do that? And then describe 1 abstract activity. This is kind of starting to build that bridge over to fluency, which we'll talk about in a later module, but I want you to start thinking about it now. All right, so in this part of this module, we've been emphasizing the concrete representational abstract. And why have we been emphasizing that? Because we can use it within a DBI framework to help students understand mathematics better. So where does the concrete representational abstract framework fit? Well, it's really here with our instructional platform. And then when we adapt interventions, often we might want to use different types of manipulatives or more representations to really help the students develop a strong understanding of mathematics. So as I think about the concrete representational abstract, it's really focused in these orange pieces of the DBI framework. Now, another side note, we just talked about explicit instruction in the previous part of this module. And concrete representational abstract cannot be used without using explicit instruction. So I can't just throw a bunch of manipulatives on the desk and say, here, kid, go at it. That's not going to help them at all. I'm going to model how to use the manipulatives by giving clear explanations and using very concise language about what the manipulatives mean. And then I'm going to give the students lots of practice opportunities, guided practice and independent practice. And then while I'm using manipulatives or representations, I need to be making sure that I'm asking the right questions, getting students to frequently respond and do things, providing feedback, whether it's corrective or affirmative, and also maintaining a brisk pace. And this part here is always about being very planned and organized. And if you are going to use manipulatives, you better have them all ready to go. You can just like pass out little baggies of manipulatives so that you can maintain a brisk pace of this lesson. Now, why is it important for us to think about the concrete representational abstract? I hope that I've kind of made it clear that it helps students in terms of seeing and understanding mathematics in different ways. And really here, I'm just trying to fill your toolbox with tools that you can use within intensive intervention. Not every time you teach mathematics will you use a concrete material or a representational material. But I would hope that you will reflect upon the intensive intervention that you're developing within that instructional platform and think, would it be helpful if I brought out a certain tool, a certain manipulative to use? Would it be helpful if I drew this, or if the student drew this, or if we looked at a virtual manipulative? Those are things that are going to help students have a better, stronger understanding of mathematics. So we're filling your toolbox with the idea that you should use the concrete representational abstract probably more than you're using it now. So to finish up this module, I want you to look at this checklist. So when I ask myself, how should multiple representations be used within intensive intervention? Well, we want to use 3-dimensional concrete materials to help students understand both concepts and procedures. We want to use 2-dimensional representations to teach also concepts and procedures. And we also want to make sure that students understand mathematics in the abstract. That is with numbers and symbols. So now with your classmates, I would like you to talk about 3 manipulatives or representations that you use on a regular basis. It's always great to talk to other teachers and say, what are you doing? Because a lot of people are doing some really cool stuff with the concrete and representational. So I'd like you to describe those to your classmates and also talk about the pros and cons of each of those.